Okay, so this is section 4.6, and we are writing equations in slope-intercept form. So first of all, let's start by remembering what is slope-intercept form, and that is y equals mx plus b, where we have m, which is the slope, which is y2 minus y1 over x2 minus x1. This is also the same as saying the rise over the run, the change in y over the change in x, how much it goes up or down versus how much it goes side to side. So, if we have an example that says to write an equation in slope-intercept form that passes through the given points. Now, so if I have this, and we're going to say I have a graph with my y and x, and it goes through this point and this point. This is the point 0, 4, and we have the point 3, 1. Reading my graph from left to right, this is going to be point 1, and this is going to be point 2. Now I use my formula, m equals y2 minus y1 over x2 minus x1. And y2, my y from point 2 is 1, minus my y from point 1, which is 4, over x from point 2 minus x from point 1. Now we can do 1 minus 4, that is negative 3. 3 minus 0 is 3. Negative 3 divided by positive 3 is negative 1. Now I can start to write my formula. I would have y equals m, which we just found was negative 1, x plus, and I know my b is going to be positive because it crosses above the x-axis. And it crosses when x is 0, y is 4. So this point here is my y-intercept, and it was one of the points that we were given. So this is my answer. Let's try another one. We are still going to write the equation in slope-intercept form, but this time my graph looks a little different. So I have a scale of 5 and 10 on my y, and my graph looks like this. And this point here is 0, 7. I have a horizontal line as my graph. The slope of a horizontal line is 0. This would be 0 over the run. And it doesn't matter where I go, y is always 0. It doesn't matter what x is, so this is just going to reduce to 0. Now if I go to write my equation, I have y equals m x plus, and it crosses my y-axis at 7, positive 7. You can leave this as your answer that shows that the slope is 0, or you could write this as y equals 7. Either one are fine. Let's do another one. I have y and x, it's 2 and 2, go this way a little bit, negative 4. Now this one is going to have the points negative 2, 1, and 2, 3. And connect them. This is the point negative 2, 1. Now to find my slope, reading from left to right, I have point 1 and point 2. So this is going to be m equals my y from point 2, which is 3, minus my y from point 1, over x from point 2 minus x from point 1. So I have 3 minus 1, which is 2. 2 minus a negative 2 is 2 plus 2, which is 4. This can be reduced to 1/2. So my slope is 1/2. So my equation would be y equals 1/2 x plus, and it crosses at y equals 2. You can count with your slope, up 1 and to the right 2, and that lands exactly on this point. You can look at your graph if it's drawn to scale, or you can use your formula. And in your formula you would put 0 as x, and then what is your y? That's your y-intercept. This is our answer. Now let's try one more. And we are going to say that we have a table. The table shows the speeds, which is y, in miles per hour, of a car after x seconds. X seconds of braking. So the car is slowing down. They're pressing on the brakes. Write an equation of the line that passes through the points in the table. Then interpret the slope and the y-intercept. So my table has x and y at 0, 1, 2, and 3. And y goes from 85, 70, 55, and 40. So this car starts out at 85 miles an hour. It's slowing down pretty quickly. It was going pretty fast. So to find my slope, I'm going to pick a point. Let's call this one 0.1, this one 0.1, and this one 0.2. So I have my y from 0.2 minus my y from 0.1 over my x from 0.2 minus my x from 0.1, and I get 15, negative 15 over 1. So my slope is negative 15. Then my y-intercept. They didn't give me a graph for this one, but I can still figure out my y-intercept. I know that where it crosses the y-axis, x is 0, and it tells me x is 0 here. So I have 0 and y equals 85. Now I can write my equation. I have y equals m x plus my y-intercept of 85. That's just part of my answer. I have to interpret the slope and y-intercept. So then my slope of 15 means that the car is slowing down by 15 miles per hour every second. When B, my y-intercept, is 85, means that the car was going 85 miles per hour before it started braking. Or at the point that they just started hitting the brakes, they were going 85. I don't know what they were doing before they hit the brakes, but right when they hit the brakes, that very second they started that, they were going 85 miles an hour. So all of this is part of your answer as well.